Hello, good morning, Honorable Prasanta. This is Dr.M.Vignesh Kumar from Civil Department in the PSN College of Engineering and Technology, Tirunelveli. Here I discuss about the topic of hyperspectral remote sensing. Remote sensing is a great tool to study the satellite image to identify any particles precisely. At that time, remote sensing has two types. One is the optical remote sensing, another one is the non-optical remote sensing. Optical remote sensing means it will work with the sun rays. In this optical remote sensing, it has three types. One is the multispectral remote sensing, and second one is the hyperspectral remote sensing, and third one is the ultraspectral remote sensing. Multispectral remote sensing means a satellite has number of bands around 12 bands, that it is called as multispectral remote sensing. Example: Landsat TM, Landsat ETM, Landsat ETM plus, Landsat OLI. This kind of satellite images are the multispectral imagery. At the same time, we are having the number of bands around 242 bands in one layer, that it is called as hyperspectral imagery. In this hyperspectral imagery, example is Hyperion, AVA arrays, and Cassie imageries. Nowadays, Hyperion play a major role to identify any kind of vegetation and mineral in a precise manner. So, in this point of view, we are going to identify the mineral composition using the hyperspectral remote sensing in a Hyperion satellite imagery. So, first one, we are going to focus on the limestone mining. So, limestone is mainly a sedimentary rock composed of calcite. It is mainly used for the cement industries. Especially, we are living in Tirunelveli. In Tirunelveli region, Sankar cement and Indian cement region is there. It is available in highway of Madurai district. It is the place is called as Talayuth. So in this region, CaCO3, this kind of composition is the purest kind of composition. Is that means the industry is having the major amount of limestone. It is mainly used for the manufacturing of cement. At the same time, the calcium content is low. At the same time, magnesium and other composition are rich, that it will be mixed with the various compositions like dolomite, feldspar, biotite, and quartz also. In this various compositions are mixed composition, it will be used for in the chemical industries like bleaching powder, soda preparation, and calcium carbonate generation. So, in our main objective is to produce the limestone mining activity in the area in a very precise manner, because in this limestone mining it's a open cast mining. Mining also having two types. One is the open cast and another one is the closed mining. But in the open cast mining, they are not taken the purest form of limestone mean, they are taking the number of waste also. In this number of waste, they are directly put on the ground, and that surrounding people definitely they will affect by the mining waste. What kind of waste means? One is the noise pollution, groundwater pollution, affect the vegetation, increase the surface temperature and water level also. So noise pollution is carried out by the bomb blasting and transportation activities. At the same time, it's a calcium carbonate. The calcium carbonate content is there in the waste, means the waste particle mixed with the water body. At the same time, it will mix with the rainfall. In this rainfall composition mixed with that means it will penetrate into the ground. After that, it will create as a leachate. In this leachate, definitely create a warm for the bone on the people problem. So in this groundwater pollution also too high in that region. At the same time, the vegetation, improve vegetation quality also, it will be definitely affected. At the same time, agriculture yield, everything is reduced. At that particular region, in that mining region, the April May temperature will reach around 50 degrees Celsius also, and the groundwater quality also going too low. So for that thing, we are going to identify the purest form of limestone using the hyperspectral. Is a very precise thing. So previously they are not identified the mineral composition. They are already identified, but they are not identified for the Indian climatical condition, because in everywhere they are creating the spectral libraries. UHGS, JPL, JHG is there. UHGS means United States Geological Survey, and JPL means Jet Population Laboratory. This every laboratory focused on US weather condition, how the minerals is there, how the reaction is there. For that thing, they are taking the spectra. In this spectra only, they are taking that and they are doing the classification approach and they are giving the mapping. We are doing also the same thing. But in our point of view, we need to generate the spectra for our Indian condition. So for that thing, we need to generate the spectra for Indian condition. Mean we need one instrument. It is called as AST spectroradiometer. So in this AST spectroradiometer, it is used to produce the spectra from 400 nanometer to 2500 nanometer. Overall, 0.3 millitons of waste already established on the region. So we are going to identify where the purest form of grade limestone is there means the compared to the traditional approach, they will extract the particular feature in a very precise manner. So for that thing, we are going to take the Hyperion satellite imagery first, because Hyperion is the one and only free source satellite imagery in our area. So this is our study area. This is the mono black of our Tirunelveli district. This is the exact part of limestone Taluk region. So in this thing, you can able to see that red pixels are available in that area. These red pixels are indicate the purest form of limestone. But we are not able to say that it is a purest form of limestone only. It will be mixed with the various composition like biotite, quartz, feldspar, and other thing. So we need to do the sampling analysis first. So in the sampling analysis, we can able to fix that what kind of mineral is there, what kind of composition is there, what is the grade of mineral is there. For that thing, we are going to take it. So in this mapping, it is developed using the RGS platform. So this is our study area location. The latitude and longitude information also given. So our first objective is to identify the various kind of mineral composition based on the spectral signature. So for that thing, we need to collect the minerals based on the chemical parameters using the SEM and EDS method. SEM means scanning energy microscope, and EDS means energy differential X-ray spectroscopy. So in this instrument, it allows to fix what type of mineral, what is the mineral composition is that. And next one is to develop the spectral signature. For that thing, we are taking the AST spectroradiometer. So in this AST spectroradiometer, develop the spectra from 400 nanometer to 2500 nanometer. So in this range, we are taking the spectra means we need to take the signature in the laboratory condition, after that field condition also. Finally, we need to compare the spectra to the EAGS spectral library and JPL spectral library as well as JH spectral library also. After that, we need to download the satellite imagery first. So this is the Hyperion satellite. Hyperion is the 16-bit radiometric resolution satellite. It has 16 days receive period. So in this Hyperion satellite has the 242 bands and the spatial resolution is 30 meters. So in this Hyperion imagery has 242 bands means it's a large amount of bands. Due to the large amount of spectral information, we can able to identify our limestone mineral very clear manner. But every bands are not in the available condition. Some bands having the zero values and bad bands also there. The noise level also too high. So for that thing, we need to identify what's the band available in the good condition in a calibration mode. So finally, we are carried out of 242 bands, 163 bands are available in the working condition. And next one, to remove the vertical strip. In every Hyperion imagery, CCD array will be referred to the other images. So like this point of view, we can able to see some black line as well as white line in the imagery. So it will be produce the problem in the visualization as well as it will be affect the precision in the classification approach also. So for that thing, we are going to remove the strip removal using the local destripping algorithm. So compared to the number of algorithm, global neighborhood algorithm and low pass filtering, high pass filtering, wavelet oscillations, local destripping algorithm will modify only the nearest neighborhood pixel value. So it will based on the nearest neighborhood pixel value. Like example, that middle one is 0 and neighborhood pixel value is 10 and 12 means it will take the average 10 plus 12 equal to 32 by 2 equal to 11. So middle pixel value is like 11. This kind of average it will take. So local destripping algorithm will give the better result compared to others. And next one is to produce the absolute reflectance value. So reflectance means it will give the two type of reflectance. One is the relative reflectance and another one is the absolute reflectance. First, we will see what is the reflectance and radiance first. When we switch on this room in a light mode means in that light EMR electromagnetic spectrum will come to me. So in this EMR is coming to myself means in this light it will come to the rays means in this rays it is called as the radiation. At the same time it will be touched to my skin and reflect to yours in a mirror. Otherwise camera that it is called as a otherwise your eyesight means it is called as a reflectance. In a reflectance, I will look like some black skin because in my skin tone, metamelanin content is too high. So for that reason, I just look at a very black skin tone person. So in this kind of same approach, it is available in every kind of Earth surface feature in satellite imagery. So in the satellite imagery, radiance is our sun rays. After that, it will be send and it will be touch or particle means that reflectance value we will carry it out using the flash atmospheric correction method. At the same time, the same reflectance value will be get ourselves using the field condition using the AST spectroradiometer. So in this project, we need two things. One is the satellite imagery in a field spectra condition. At the same time, the AST spectroradiometer also in the field spectra condition. After that, in that Hyperion imagery having the three regions. One is the visible and VNIR and SWR imagery. Visible and VNIR means visible region. It is normally 0.4 to 0.7. It will be visible on our eyesight. It is normally denoted as RGB layers. After that, VNIR means very near infrared region. So in the visible and VNIR means it is used to identify for the mineral composition mapping, vegetation composition mapping. At the same time, shortwave infrared region that is from 1200 nanometer to 2500 nanometer, it is used to identify the mineral composition mapping. So in this limestone, it is a one part of mineral. Normally in world, 5,800 types of mineral is there, and 5,030 minerals are associated by the International Mineralogical Association (IME). So in that thing, we are taking the limestone as a calculate as a one part, and that limestone mixed with the various composition also we are going to take. After that, we need to do the data dimensionality reduction using the minimum noise fraction and pixel purity index method. The minimum noise fraction is to remove the spectral data reduction and PPI pixel purity index used for remove to identify the spatial data reduction. After that, we are taking the NMember of mineral sample. In this NMember mineral sample, we are developing based on the property score of three methods. The methods are SAM, SFF and BE. SAM means Spectral Anglemapper and SFF means Spatial Feature Fitting and BE means Binary Encoding. After that, we are going to classify and generate the mineral mapping based on the spectral signature. For the spectral signature generation, lot of classification is the like perfectional classification approach and subpixel classification approach. In this perfection collapsing event approach, the spectral angle mapper and spatial feature building, binary encoding, linear spectral and mixing, lot of methods there. But in our point of view, we are going to do the spectral angle mapper SCAM method only. So this is our first objective point of view. We are taking the mineral sample first. So in this mineral sample we are taken means you can able to see that in the first mineral there is only the iron ore formation is there, and the second mineral is a purest form of calcite composition is there, and third mineral in the white part it's in the green part it is represent the feldspar, and the yellow part represents the dolomite, and the black part represents the iron ore leachate. And next one you can able to see that white pixel it's represent the limestone, and the green pixel are represent the feldspar. So this kind of various composition we are taken, and the quartz also is there. So identifying the chemical composition of the limestone, because I am not a geological person, so I just take the sample means I will take the scanning electron microscope instrument and EDS instrument. This instrument it will give the microstructure of our study area. So we will take the sample and we need to do the dust particle like that. So we need to do the dust particle like that means after that the samples are the non-conductive materials like that. So in this EDM the scanning electron microscope we need to do the instrument analysis mean the material will be the conductive material. For that thing we need to apply the carbon coating on the top of the layer first. When we apply the carbon coating means the electron first that will be the negative will directly move to the electron beam to the positive. So in this EDS graph sheet also is giving that. So in this left side figure you can able to see that is the microstructure of the purest form of limestone only. It's a pure form of calcite. On the right side you can able to see that it is the limestone availability in the graph sheet, like CaCO3 contents are too rich, but you can able to see that in the graph sheet MgSi also is there. Mg is nothing but magnesium and silica is there, but that composition is too low. You can able to see the percentage that magnesium is 0.9 and silica is 0.13 only, but CaCO3 is too rich. Around 99% is CaCO3 only is there. So from that we can able to say that that's the purest form of limestone. So in this other mixed composition limestone microstructure and that EDS graph sheet also is shown in the figure. Please just see that. So after that we are going to develop the spectral signature. In the spectral signature we are going to develop using the spectroradiometer. So this is the instrument, the spectroradiometer. So in this instrument we can able to generate the field spectra and laboratory spectra in the visible and VNIR region and SWIR region for every materials in the earth surface. Not only soil, vegetation, mineral, rock, what kind of thing is that? For example, in this classroom we can able to see some window and window seat and some AC, and that AC, plastic, metal, everything is there. We can able to generate the spectral signature using the AST spectroradiometer in the 400 nanometer to 2500 nanometer. In that range, it will give the resolution. The various resolution is the 10 nanometer, 100 nanometer, 1 nanometer also there. But we are taking the 10 nanometer because our satellite imagery also having the 10 nanometer spatial intervals. In that instrument also having the 10 nanometer spatial interval means it's may better. Otherwise, we need to do the spectral resampling works also. Okay, next one. And this is the limestone and its spectral profile flat. So in this limestone, we can able to see that means it will be giving a very deep absorption around 2000 and 2300 nanometer. So in this graph sheet, you can able to see the data value. This data value is nothing but a reflectance. After that, in this x-axis, it will be denoted as index. Index is nothing but a wavelength. It is in the nanometer range, 500 nanometers to 2300 nanometer. In this kind of range is the, and the reflectance will be coming from 0.4 to 1. So we are going to get a deep absorption in the short wave infrared region, means due to the calcite content only. So this calcite content, it is used for to identify our limestone in the very precise manner. So we are taking the number of samples because it is like a trial and error method like that. Because we are not able to say that only based on only one sample that is the purest form of limestone. So for that thing we are taking the number of limestone and the spectral signature, and we finally observe every spectral signature showing the huge reflectance in the 2300 nanometer. It's a huge absorption is there. After that 2400 nanometer, a huge reflectance also there. Based on the graph only, we can able to fix our spectral indices and the mapping technology also. So this is the spectral data for our purest form of limestone only. And next one, this is the limestone mixed with the various composition. In this limestone mixed with the various composition mean it is also giving a very huge absorption in the 2300 nanometer. But you can able to see that a number of fluctuation in the spectral signatures. For example, in a calcite giving one spectral signature, but the calcite and biotite will give the spectral signature in a blue color, means that absolutely variation will be there. Because in this thing, we can able to find it out. A calcite and biotite, the composition is that, means the composition will give the various result. For that thing, we need to identify what is the purest form of calcite. The purest form of calcite only the our purest form of limestone material, it is used for the cement industry. But calcite are mixed with the biotite, quartz and dolomite, feldspar, means it will give the various spectral signature. So we need to find it out that things also, because in that limestone region, that mining region, it is not only filled with the calcite mineral only. That various composition also is there. Okay. So for that thing, we need to take that signatures also. And next one, that is the backbend removal of Hyperion imagery. First, we need to download the satellite imagery first. So for the satellite imagery download, you are taken from the USGS Earth Explorer. That website is there. That earthexplorer.usgs.gov. It is useful to download the every NASA satellite information like multispectral, hyperspectral, and damage measures, everything in a same way. For that thing, we need to create our login and password. After that, we can able to choose our polygon region. Then we can able to download the area. So in that Hyperion dataset, we can able to download using the three parameters: LNR, LNGST, and LNT. So in our area, we are taking the LNR imagery for ourselves. So LNR is a radiometric calibrated file, as well as the 4 points are georeference to one. So we don't need to do the georeference once again. So in a Hyperion imagery, previously we already say that the Hyperion imagery is not contain every imagery having not contain the pixel information. It will be having some zero band. There is no pixel information. That no pixel information is called as zero bands. It is available in band number 1 to 7 and band number 225 to 242. At the same time, overlap region also is there. It is 58 to 76. And the water vapor also having the very noise, it will be coming there. So the very noise level is there, means that due to the heavy noise pollution, we are not able to identify any kind of information in the picture. It is available from 120 to 133 and 165 to 182 and 221 to 224. So in the sample representation for zero band, it will be shown in your left side figure, and bad band, it will be shown in your right side figure. After that, we can able to get that bad band means on that bad band removal, it will be create the spectral profile plot variation in your spectral library also. You can able to see that in the spectral window. In this first left side figure, you can able to see that the zero band and overlap region, and next one zero band is the in the zero band and overlap region, and next one zero band, we can able to see that the spectral signature is going down to zero. It is totally nothing value. But on the right side figure, after removing the bad band means the sudden up and downs, the sudden values, the spectral signature values going to the zero, it will be totally avoided. So for that thing, we need to remove the bad band removal first. Otherwise, it will be affect your precise level classification of limestone imagery. And next one is the stripping availability in Hyperion. So we already say that in this thing, in this satellite imagery, number of images will affect by the stripping imagery. In the stripping is that in the strip it will be a black strip as well as white strip. As well as in the black strip or white strip, the value is adjusted by the neighboring pixels value. So you can able to see that in the I just give that what's the band, what's the column, what's the value, like that kind of values I already given. In that value, 0 or negative mean it is come as the black strip. Otherwise, double means it's going to come as the white strip. So in the next image we can able to see that in the left side figure, you can left side figure first image we can able to see that a black line is there. It is called as a black strip. And next one image, the white line is there. It is called as a white strip. So in the right side images, we are removing the both black strip and white strip. At the same time, in the left side spectral window also we can able to see that in that black strip is that means the sudden fluctuation is there in the spectral profile plot, and that white strip also it will give the variation is there. But after that we are removing the spectral signature. We are removing the stripping effect means we can able to get the very smooth signature in the output. So in this de-stripping process, it's not only enhance the visualization only, it will be increase the spectral signature response between the image spectra in the field spectra and the classification approaches also. And next one is the flash atmospheric correction model. So lot of atmospheric correction model is there. Compared to the lot of atmospheric correction model, 4S algorithm, 5S algorithm, ATRIN, ACRON, and flash, lot of algorithm is there. Out of lot of algorithm, we are taking the flash atmospheric correction model will give the better result in the absolute value generation from 400 nanometer to 2500 nanometer. So in this range, the flash atmospheric correction means it need some basic information about the ground area, like scan center location, ground elevation, and sensor elevation. Sensor elevation nothing but that satellite elevation. Pixel size is nothing but a spatial resolution of the satellite, and the flight date. Flight date is nothing but a satellite image when we are downloading from our Explorer website, and the atmospheric model, aerosol model, water reservoir, and intervisibility, spectral policing, and adjacency correction, wavelength calibration, CO2 mixing ratio, output reflectance scale factor, tile processing, mortar, and disorder, and mortar resolution also. So this is for our particular study area only. It will be changed for any area. So when we do any kind of satellite imagery correction means it may be a hyperspectral or multispectral or ultraspectral. We need to do some basic process. First one is the raw imagery. After that, we need to identify the calibration band, that is we are denoted as a bad band removal. After that, we are going to do the radius conversion and the reflectance generation. So in this bad band removal, after that we are doing the radius conversion using the radiometric calibration tool is the In this radiometric calibration tool, we can able to generate using the three method: BSQ, BAL, and PAP. BSQ means band sequential, BAP means band interleaved by pixel, and PAL means band interleaved by line. After that, we will carry it out using the reflectance generation. In this reflectance generation, a lot of methods is the flat field, IAR, empirical beeline, and 4S, 5S, Acron, Attrib, and flash. So in that thing, flash atmospheric correction model will give a better result compared to other. So for that thing, we can able to take the flash atmospheric correction model will give the better result for ourselves. So in this spectral profile flat, we can able to see that for one particular pixel in a 30 into 30 size pixel, it will give a variation in the raw and backbend removal and radiance and plus atmospheric correction also. So after that, we are doing the data dimensionality reduction. So in this data dimensionality reduction is used to identify our NMember. NMember means it's like a training sample. Normally we know to do any kind of classification means two things is important. One is the testing sample and another one is the training sample. So this training sample means it will be carried. For example, we are going to identify our area in it is a land use land cover imagery means in this land use land cover imagery, how many buildings, how many road sector, how many water body, how many things that means we need to identify. That means it will be carried out using the our basic instrument like toposit and old maps and the field visit also. Like this kind of remote sensing part work, we are doing the analysis in a spectral profile flat generation using the AST spectral radiometer. But we need to do the data dimensionality reduction means it will be used to minimize the spectral data information and spatial data information and find out the very pure pixel value. Based on the pure pixel value, we can able to identify ourselves in a very clear manner. For example, MNF is the minimum noise fraction. In our Hyperion imagery, it will give around 163 reflectance band. In this 163 reflectance bands, some band will having the very nice information, some band will have the less nice information. When we apply the MNF transformation means that MNF transformation will totally arrange the Hyperion imagery based on the noise level in descending order. That means the band number 1 means it may be a no noise, band number 10 means less noise, and band number 20 means heavy noise. This kind of arrangement it will done. So in this left side figure MNF band 2, you can able to see that the noise level is too less and band number 20 is the noise level is too high. And next one is the pixel purity index. When the noise level noiseless bands are we are carried out MNF means we will take only the 10 bands, we will give the input for the pixel purity index. In this pixel purity index, fix the threshold value on 2.5 and it will be do the iteration of 10,000 times. Then it will give the black pixel and white pixel, it will be given in the imagery. The black pixel represent the impure pixel and white pixel represent the pure pixel. So in this data dimension representation, ultimate aim is to develop the spatial and spectral pure pixels. So in this spectral purity identification is done by the MNF method and spatial purity identification is done by the PPA method. And next one is the NMember generation. The NMember generation we can able to carry it out using the three methods: binary encoding, spectral anglemapper, and facial feature fitting. So for that thing, we need to take the spectral signature for ourselves using the AST spectral radiometer. After that, we need to compare the spectral radiometer with the imagery spectra. Some person will do the spectral radiometer comparison with the UAG spectral library, JPL, and JHE spectral library also. So after that, they will assign a rank for every sample, and they will fix the threshold limit also. And this is the NMember property score for our samples. So in this calculate, it will give 0.82, 0.849, 0.863 means that is the important for our cell, because that is the purest form of limestone for our study area. It will be given for 2.532. Then the SIM means it's for property score for out of 1. SIM means out of 1. B means out of 1. So the total is 2.532 out of 3. So this calculate information and calculate plus biodate. What is the heavy level of property score is given means that heavy level of property score value only we are going to take it. This property score we can able to fix using the n-dimensional visualizer and SAM, SFF and BE method only. Finally, we are going to do the spectral angle mapper. This spectral angle mapper, it is used to identify the spectral similarity between the imagery spectra and reflection spectra, and the formula also given below. Then we are going to identify the imagery classification means in this imagery classification the flash atmospheric correction value, it is our testing imagery, and the training samples are the NMembers. So like that wise we are taking the imagery spectra and reference spectra. The imagery spectra means it is the flash atmospheric corrected imagery, and the reference spectra means your training samples, otherwise NMember spectra, otherwise it may be a field samples test in the AST spectroradiometer in that 400 nanometer to 2500 nanometer. But in the spectral angle mapper, we need to carry out the information from 1200 to 2500 nanometer. We need to select the particular bands only, otherwise it will give the very large amount of information, because that is not now necessary. We need to identify the limestone band. That limestone signature will give the very huge level in 1200 to 2500 nanometer. For that thing, we will get that from SWIR region only. And next one, this is our final output. In that thing, we will get the mineral classification. In this mineral classification, we can able to see some red pixels and black, red, cyan, yellow, magenta, a lot of colors is there. So in this left side figure, we are developed our own mineral composition, and right side figure, it is already developed for that area. It is available in the Geological Survey of India. In the Geological Survey of India, they will say that only the quartz, and they will say that small amount of biodite and a limestone quarry is there. They will just say that limestone quarry, biodite, that thing only is there. But in our point of view, we will get that what's the percentage of quartz in that area, and what's the pixel count, and what's the area. For example, in our calcite, in that calcite it is 749 pixel count is there, means in the 749 the spatial resolution of Hyperion imagery is 30. So 30 into 30 it is equal to 900 meter square. The 900 meter square into 749 equal to 0.6471. So 0.6471 kilometer square, a purest form of limestone is there. And next one is the calcite. Sorry, the dolomite. Dolomite is 0.10162 kilometer square is there. And dolomite plus calcite, that composition is there. It is 0.423% kilometer square is there. And feldspar is something too less level only. And calcite plus biodite also is the 0.0891 kilometer square. And calcite plus quartz is the 0.9405 kilometer square. So in this thing we can able to see that the calcite is storage in three manner. That calcite plus dolomite, calcite plus quartz. So we need to carry out the purest form of calcite, that will be represent the red color pixel. that calculus plus dolomite it will be represent the yellow pixel, and calculus plus quartz is represent the purple color. So finally we can able to say that in the calcite it will be carried out in the spectroradiometer in a very precise level manner, and we will get around 0.6741 kilometer square for our study area. So it is only for this area only. In our future implementation, they are going to identify the new limestone factory, otherwise, new cement factory means a new limestone mineral exploration means we will do the analysis for the nearest neighborhood areas also. Not only a Hyperion imagery, we will carry it out using the AVARS and Landsat imageries also. Finally, we can able to identify the purest form of mineral classification, because in our traditional approach they are doing the analysis, they will give the limestone, they will give the biodate, that information only. What's the purity, what's the purest form, they are not doing that. So this is our ultimate aim, to do the extraction in a precise manner. It will be useful to reduce the pollution, and it will be reduce your waste level generation in your study area. That's it. Thank you.